Okay, so I'm now going to show you more animation about the AC generator. Okay, so we have this is an AC generator. I'm going to click on start to show you how does it works. Okay, these are the different parts of an AC generator. You have a coil. Okay, so the purpose of the coil or more details of the coil are the coil of wire is insulated and is attached to a shaft, okay, which is this light gray one. Okay, rotating the shaft will rotate the coil, so the coil is being rotated, and then you have carbon brushes or graphite brushes, and it rubs against the slip rings, connecting them with the rest of the circuits and allow them to rotate. Okay, and you have slip rings attached to the coil, and it rotates together with the coil, ensuring that the circuit is completed at all times, and it also allows alternating current to flow in the um, external circuit, which is this one that is connected to the galvanometer. Okay, next. So, as the coil rotates, it cuts through the magnetic fields, and this creates an induced electromotive force or an induced voltage in the coil, and this in turn will create a induced current once there's a complete circuit in the external circuit. So let's take a look at how does it happens. When the coil is horizontal, okay, the EMF and the induced current reaches their maximum value. This is because the coil is cutting through the magnetic field the most rapidly. So this one has the most cutting, and therefore the EMF is the maximum. Okay, when the coil is vertical, there is no EMF because the coil is not cutting through the magnetic field. So at this particular point, there is no current flowing. So you see the galvanometer becomes zero. And as the coil rotates past the vertical side, you'll see that the orange part becomes over this side. Okay, the sides of the coil again move through the magnetic field, but now it's in the opposite direction. So the current uh, EMF is also induced and the current is also induced, but the current changes direction. So the current now becomes negative. Okay, so then here is how the current or the EMF versus time looks like. When there's an EMF, there'll be an current induced. So I will just play this. You can take a look. When it's vertical, the current becomes zero. When it's horizontal, the current becomes maximum. And as it rotates, the current becomes positive or negative, positive and negative. So it's an alternating current. Okay, so the graph looks like this. Okay, I'll continue to play for a short while. You can continue to visualize it, and you can pause the video at any points that you want. Okay, let's move on. Okay, so what effects will these factors have on induced current? Okay, so how do I increase the induced current or decrease the current? Okay, the first one, rotate the coil faster. If I rotate it faster, there will be increase in the rate of magnetic flux linkage with the coil. So the induced current will increase. Use larger coil will increase the current. Use smaller coil decrease the current. Use fewer coils will decrease the current. Rotate the coil slowly will decrease the current. Use more coil increase the current. Use weaker magnets will decrease the current. And use stronger magnets will increase the current. Okay. Okay, next one. So true or false, the generator is similar to motor except that it converts mechanical energy into electrical energy. True. Okay, it's exactly the same as a motor, but it's reverse. Okay, motor is converts electrical energy into mechanical energy, but generator is converts mechanical energy into electrical energy. So answer is true. Moving a wire inside a magnetic field will induce a current in the wire. True. Okay, whenever there is a force and there's a magnetic field, there will be a current induced. Okay, a higher current can be generated by rotating the coil more slowly. Okay, this is false because you need to rotate the coil faster in order to generate a higher current. Generator always produce direct current is false because generator produce alternating current. Okay, a stationary magnet inside a coil of wire does not produce a current. True. Okay, you need the magnet to move or you need the coil to move in order to produce an induced current. Okay, so stationary one does not produce. Generator is similar to a motor except that it converts electrical energy into mechanical energy. Wrong. Generator generates electrical energy, so it converts mechanical into electrical. So this is false. Okay, let's move on. Let's start a multiple choice quiz. In which direction will the wire move? Okay, so in this case, I'm interested in the movement. Okay, so the wire will move because there is a force, and in this case, a battery is given. So I'm supposed to use my Fleming's left hand rule. So if I were to use my Fleming's left hand rule, magnetic field goes from north to south. The current is going downwards in the wire here. Okay, I will have a force that is up, and the movement will be up. Okay, so this one is using Fleming's left hand rule. Okay, got a force. Okay, I'm not asking for direction of induced current, so Fleming's left hand rule. Next, which of these will not increase the size of the force acting on a current carrying wire? So things that affect the force will be the current and the magnetic field. So which one will not increase is change the direction. If I change the direction, I will only reverse the direction of the force, but I will not increase the size of the force. Which part of the motor is this? So this green and orange, this is a DC motor. There is a split in the center, it's a split ring commutator. Next one, what is the role of the split ring commutator in an electric motor? Okay, so split ring commutator is to enable the coil to rotate in the same direction using DC. Okay. Next, which of these will not increase the speed and strength of rotation of an electric motor? So I will not increase is reducing the current. If I reduce the current, I would reduce the speed and strength of rotation. Okay. Next one, which of these will result in an electromagnetic induction? So if I want to have electromagnetic induction means I want to induce current. So I need a movement. So a wire must move and it cannot move in the same direction. It must be cutting through a magnetic field. Okay, next, which of this statement is true? DC generators are more powerful. No, they are exactly the same, just works in opposite. Slowing a generator will increase the induced current. No, it's moving faster, rotate faster, then will increase the induced current. Generators are essentially motors running in reverse. Yes, this is true. Next, which part of a generator is this? The orange and the green one. Okay, this one belongs to the AC generator. They are called slip rings. Next, what is the roles of the slip rings? The main purpose is to enable the rotating coil to produce alternating current. Okay, take note, generator produces alternating current. Next, last question, which of these will not increase the size of an induced current? Okay, I want to increase the size. Which one will not increase the size? Increasing speed, yes. Use an electromagnet. Use fewer coil, this. Okay, use fewer coils will decrease the size. It will not increase. Okay, that's it for